Okay. Okay, so Twitch is complaining that I'm streaming with too high of a bit rate, but we will see if that becomes an issue later. For now, it seems fine to me. So we will continue where we left off yesterday with the Mandelbrot viewer. Now, yesterday, we can start with this one. So without using those files, basically we just got an GLFW window up and started working on that. But then we tried to add this, add a shader and stuff. Well, that call needs to be uncommented as well. Oops. So when we try to add this one, we would just get a seg fault in the graphics driver. Now, I think that is simply because I forgot to draw any triangles, which, yeah, that was smart. So we will see how this goes. Basically, we're just using a triangle strip. We only have two triangles that need to be rendered. So this should work well. And it's just static. They're never getting updated. So we have a look. It still doesn't like that. So we will have to check this again. That's interesting. So this over here, clear this. This is entirely in the, well, it's in a different thread, so there's not much we can do about that. So, let's kill this, yes. So we'll have to do a little bit more debugging here. Let us see. I thought we set GLU's program. We did set that. And the shader all compiled fine because we were checking if we were getting a -1. Now, we didn't actually check this. I haven't had a problem with this before, but that could be the issue. What I think is, I don't think it is that likely that that is the case. So usually I am not checking those values. Um, Now, on the other hand, usually these shader types can be U32s, so it's possible that by trying to be smart here and returning -1, more specifically in this function, we're having an issue. So I think they can't be 0 actually, so I can return 0. Um, this one can still return -1. If either of these are 0, we will return a -1. Let's try this case. That is still not quite correct. So one thing, I don't know if I did it here, but just before we delete this, we can just make sure that these shader data look correct. So v.len and to standard out, and then f.data, f.len, and then I will just do an fput_c/n standard out. We can try this and see and make sure that the shader source looks correct. So there's no issue here. There's no like extra data or anything. But actually try this. So maybe I should just check this is valid. Go to my friendly website, Learn OpenGL, which anyone who's learning OpenGL or has used OpenGL knows is a good resource. Now for them, they are claiming that this should work. So what is the problem? Just need one output vector for we have here. That is fine. And in the shader, in the vertex shader, again, we just need a position. And we are passing in the position, supposedly, unless we did that incorrectly. So we can check that. VAO. So yes, so it's possible that I've done this in the wrong order. I don't think it matters, but that is one issue. Have a look. So where are they? They set a 3, and then between each set of 3 values, there is no space. These are tightly packed. So yes, these are tightly packed vertices. Now, it's possible that you have to pass a z value, but I was under the impression that you did not. No, you do not. You definitely don't need to pass a z value because I've done other code where I have not passed a z value and it has worked just fine. So that is incorrect. But, well, one thing we can do is enable the debug logging since we are having an error. So to do that, we have to use debug message callback. We have to do a GL enable debug output. the Radeon drivers like to output useless compilation statistics. So I would like to disable those, which is just in this notification level. So that is that. Now we need a debug log function. So yeah, this is a fun function that we always have to write that is got a massive prototype and is really annoying. So usually I shove it at the top of the file, but we may move this to a different file later. The debug logger, it has a this source I should really look up what gets called or what gets passed in here, but we'll skip that for now. Basically, source type ID data, all of these are not very useful. Basically, all we really care about is the message length and the message and the message length, which are these two variables. So I'll just make sure the compiler doesn't complain to me about unused variables. Oh, and the level. That's the other one we care about. So usually I will do something like this. So GL error space the standard error usually, so it doesn't really matter. And then we'll do a switch on the level. We will do case first, severity high. Print, we will put a, excuse me, we'll do a, well actually this can all be, probably all be inline because these are not that long. So we will see here how this looks. We'll print a high. Oops. This might be too long, but we'll see medium. Medium. No, it's not too long. Make sure this is lined up so it's easy to read. Next is the low and the notification. So I should have disabled notification, so I think we will not handle that. Oops. I think we'll just ignore that one, but first we'll do these ones. I want to get really fancy, I can do this instead. So, and then for default, we will do the same thing. We will just do an fputs default. Use standard error. And break. How long is this if I put this over here? Sure. I think it's fine. Okay. And then the next thing we just do is print the message. Oops, message 1, len, standard error. And a new line. Standard error, not /c, obviously, but /n. So let's try running this and see what kind of output we get. Error high, GL position undeclared. Is that not what it's called? GL position? GL position undeclared. Um, that is strange. Did I load the vertex shader into the wrong shader maybe? Um, so where are we with this shader stuff? Here we are. So we read the whole file, the vertex fragment. So let's actually just check where we call this. I'm just gonna verify that Twitch isn't still complaining to me about the bitrate being too high. It's not, so that's good. Now, so vert.gsl, fragment.gsl. So that is the correct order. Vert frag. Now let's make sure that these are written correctly. So yes, the fragment shader has the fragment source and the vertex shader has this GL position. GL position is definitely a vector 4. Am I correct or am I? This is exactly what I've done previously. So ah, that is a very useless error. Thank you. Oh wait, no, that's never mind. This doesn't have to have any output. No, no, no. Only the fragment shader needs output. So all we have to do in the vertex shader is set the position. This is like identical code almost to the example code in like learn OpenGL. So strange. So so here we go. So we've got our vertex, we got this. We're going to compile a vertex shader as a GL vertex shader, which I believe is just correct. And we're going to compile. Oh, so these are not integers apparently. Oh yeah, duh. We knew that. So yeah, those were not integers. Those were U32s. Not signed integers. They were unsigned integers. So I don't think that's the problem, but it's possible. No, so GL position undeclared. Well, I don't think this is gonna solve our error, but Stack Overflow has claimed this. We can try this. I highly doubt this is what the problem is, but Okay. Oh, interface block is not allowed for fragment shader. That might be more helpful. So GL use program 1 not linked. That might be a little bit more relevant to us. Fragment shader. This should also be correct, I'm pretty sure. So output vec for color. No, this is like definitely required. Um huh. So compile shader, patch shader link program. Am I doing this in the wrong order for some way? Um okay, so usually let me take a look here. So we create the program. Um, then we're supposed to attach the shader to the program and the fragment shader to the program and then link it. So this is all looking fine. And then after linking it, you can call validate program, and then you can call, well, I mean, I don't think there's a problem with doing that, but let's delete those first, or we just activate that. So in use program 1 not linked. Out interface is not allowed for fragment shader. It's definitely got to be allowed, so huh, that is an interesting error. 'Have a look, but that should not be a problem because 0.20. That all looks good. So why is that not working? Am I just doing something a little silly somewhere? Am I like compiling this incorrectly or something? Did I forget to do something I was supposed to? Create shader type, that is correct. Let's say shader source should be this ID, and it should be one. Constant data, and a length. And then we are going to do a compile shader, and we get the shader result. I mean, I guess I can try to get the shader log if there's an error, but we're kind of like checking down here if there's an error, so it should have showed up if this was true. But we will try this for now anyways. So we need a length. We do this get info log length. We will declare an output. Well, I think I just used malloc, yeah. So that is fine. I'm gonna do it this way for now. Then we will do our call to get the shader info log. Usually I have different types for this, that's fine. So the len again, and the data pointer. So one of these is like the length of the buffer, and then the other one's like the length of the info log. I'm not really sure why you'd be passing in a different length buffer from this, but in any case. And then once we have done that, we will do a fprint f, I guess, for now. Well, let's not do that way. Let's do just fputs compiler, compile shader, standard error, and then fwrite data one len standard error, and then fput c/n. So I think usually should be have a thing at the end, and then we will just free the data that we allocated. That is how we can look at that error, but sure. Oh, you know what it is? So that's actually the output length that got written. I'm pretty sure it doesn't matter if it's the same variable, but we will see. It doesn't like that. See, we're like not getting any errors from there, as far as I can tell. But we will, just to be sure, I will assign a second len2, and we will use len2 here instead. Yeah, so there's no like, we're not getting any error. I can stop printing this stuff, I think. But did I set the GL version correctly? Yes. Oops. Now, is there anything else I am usually setting in this thing? No, so I usually just do this, and this is fine. Um, yeah, this should all be fine. Oh, so usually I'm not passing monitor here. I'm just passing null, even though I have the monitor. Um, yeah, we're still getting that error. Um, I rid of this. Oops, not the deleting, not the freeing of the data. I'm gonna do that still, but why oh why is the graphics card having problem? So that is a good question. Um, so vertex shader. How did we do this? So usually this all looks good to me. So then, so usually we do this. Possible that we need to set the GLFW error callback up so that it can give us errors. Who really knows? But I've never seen any errors from GLFW, so we can try that, but I highly doubt that is the problem. So here's just some boilerplate code that I'll just copy. Um, doubt this is what the issue is. And there's no GLFW error coming up. It is still complaining that the program is not linked. Oops. Um, why is that happening? Just make sure again that I am passing all of this stuff incorrectly, because the shader to me, I don't see why the shader would be the problem here. So it is possible that I should be setting this up sooner than when I'm doing this though. So what am I calling this in a renderer? These are all glfw commands, so that besides clear color, but that doesn't matter. So yeah, we'll set that up. We'll generate some vertex arrays. We will bind those arrays, or bind that array, rather. Then we will define some vertices, which are all the corners correctly, from what I can see there. Then we will generate some buffers for the data, and then we will bind the buffer as an array buffer. Then we will apply some buffer data to that buffer that we just bound, which is this. Everything here looks fine. And then we will do, now usually, like again, I've done this before the opposite way. From how GL vertex attrib pointer. So 0, layout 0, there is 2 floats. They are not, or they are not normalized. And I think that's what that argument is, but we can check. The index is 0. Size is 2 floats. The type is float. The normalized. Sorry, yeah, it doesn't need to be changed. It doesn't need to be normalized because it's already normalized. So we don't really even need to be specifying 2 here because they're just tightly packed into the array. So since we've set this other value to 2, we don't really need to care about the stride. Number of components per vertex attribute can be 1, 2, 3, or 4. So it is 2. There is 2 elements per vertex attribute in this float vertices. That should all be fine. Now, is it possible that the program needs to exist before I start doing this? It doesn't really make sense, but maybe it does. Maybe it does. So, but actually, I don't think I've done that ever before, so. It's probably not the case. Yeah, I'm never like binding the program before I am uh, doing this. So I don't really think that is the problem here that is causing the seg fault. We're not using any textures, so I don't need to do anything with that. Be none of this, so um, very, very interesting. GL Jan Gophers. Um, yeah, there shouldn't really be any reason why, unless there's a graphics driver bug to. So I will say I've always had at least three, but this shouldn't matter unless there is a graphics driver bug, which is possible. And I should comment out that line in the vertex shader because this should not be needed. So what is the problem there? Like why on earth would that be happening? Um, some reason, I don't know why I'm usually doing that, but that is definitely way more libraries. Okay, I'm glad that is not the problem, but so what do I do? This is completely unnecessary, but because we are just finding a single one. EGL context dot PID. I believe that is what we called it. I have no idea why this caused it to get further than before, but yeah, so oops. At least like that causes it to go to the loop, but that doesn't make any sense why we would just be getting that. I guess we always have this option of just stepping through oops. We will break well, this break at main, and we'll run not step, go over. There's many threads, so this is gonna be like really annoying without a proper sure, that's fine. So yeah, really what I should do is kill this. Oops. Yes, just thank you. This is a very good question. Usually don't have that like that, but that is not a problem. Yeah, so the main.c, we're gonna get rid of this because I already know it's not linked. We only need to link it once. For some reason, it's not linked. Now, that's a good question as to why that's happening, but um, what can I do? What can I do? So, shader result. This is honestly like completely baffling to me because I've never run into this problem before. Um, Especially because we're not doing like anything. Haven't done anything useful yet, and I've never even like yeah, I've never had to well well now I feel stupid. So before when I said am I passing the wrong shader, this is where I should have used longer names so that I would see that when I was making a dumb that would explain everything. Now let's just do this. There we go. Wow. That was some stupid that was a stupid mistake. So I want to delete some code, including this, because that is not necessary. Yeah, so main.c. Let us delete some of these. Well, probably we should keep the error handling around even though it's not really strictly necessary. I will move this function. So here now, what do I want to do next? So oh, that's just working. You know, let's just start trying to draw the Mandelbrot set. So first thing first, I just need to figure out which variables are available in the fragment shader. So fragment shader default variables, I think. So they have a fragment coordinate and a point coordinate. So let me think here. So fragment coordinate is the location of the fragment in the window space. The x, y, and z components are the window. Oh, and one other thing I should do quickly is you don't need to pass the z z in, so I will not store that in the binary data. It's completely useless. So we'll just do that. Before I forget. So that is good. Now, the x, y, and z components of the window space position of the fragment. The z value will be written to the depth buffer if GL_frag depth is not written to by this shader stage. The w component of the fragment coordinate is 1 over the clip, so that I don't think matters at all for us. I might want that one. There's also point coordinate. So fragment coordinate, point coordinate. But no, I don't want that one at all. Yeah, so all of these other the variable I specifically want is the GL fragment coordinate. So there is a vector called the GL fragment coordinate, and that is going to tell us which location we are currently at in the window, which is exactly what we need for doing our Mandelbrot algorithm. So first we need to scale the coordinates to lie in the correct what's it called? The correct coordinates for the Mandelbrot set. So we are treating x and y as two components of a complex number. So x would be the real component, y will be the the imaginary component. But for that is all fine and good. What we want to do first is just take. Now, unfortunately, these two things are not in the same space. So we need to take float x is going to be equal to GL frag coordinate dot x and dot y, and don't forget these, but we need to scale these. So these are going to be in the space what did GL say? It should be the screen space. So it should be sorry, like the open GL space. So it should be -1 to 1 is where these are existing right now. So we probably will just do our linear scaling happened here. I don't care about tessellation, anything. I just care about the fragment shader coordinates. So fragment coord and in window space. So well, that's not really clear if they mean Well, well, it does kind of matter what that means. So the W component of the fragment coordinate is 1 over W clip, where W clip is the interpolated W component of the clip space vertex position. Um, well, that is fine. I do believe that we could also use the point coordinate. Uh, that is not correct at all. All we care about is I believe we just need directly the fragment coordinate, but I will just make sure that is correct. Um, it is possible that huh. So one thing we could do is I'm pretty sure it is just this space. Actually, let us just check. So we can do this. We can see if these are correct. So if um if x is um greater than uh x is greater than 0 and let's just do this. If x is greater than 0, we will just see oops. Bad. If x is greater than 0, we will set the color to green instead of blue. Uh, Typing today. This will tell us what is going on. Oops, I didn't need to build. So since the whole screen is 0, that means that these coordinates are from 0 to um, these coordinates are from 0 to 1, right? So yes, these are actually in-screen coordinates. So if x is between, to just verify this, let's say x is less than 0.6 and x is greater than 0.4, then we will just draw this green strip. So right in the center of this screen. That is not actually, oh, sorry. Yeah, they're in-screen coordinates. So screen pixel coordinates. So we need to know what the size of the screen is to normalize the value. Um, really, I think we can interpolate it based on the position of the uh, GL should have like a way of us just figuring this out. So you can also try the point coordinate just to make sure that the point coordinate might be from 0 to 1. No. So it is not from, so the point coordinate is from 0 to 1, but it is a little weird. So let's just try this again. Let's say that x is greater than 200, so 200 pixels in, we'll get green. So what is happening? Why are we just getting blue? Um, sorry, we're still using the point coordinate. So let's go back to the fragment coordinate. Okay, so yeah, this is like the total screen width. Obviously this is so that is what I thought. Now that means we need to figure out what the width of the screen is in the shader. So um, this should technically be available unless maybe W or W clip. No, W doesn't tell us that. Sample ID, sample position, sample masking, clip distance. What are the clip distances? Clip space. So Vertex has the following predefined outputs. Clip distance allows the shader to set the distance from the vertex to each user-defined clipping half space. No, that is not helping us. Pixel width height of the point being rasterized. It has only the meaning when rendering point primitives. We're not rendering a point. Very, very interesting. So, how do we figure this one out? I think what I will just do is that doesn't make sense though. Let me just search quickly. Well, I mean, we can obviously use a uniform that we just set once. That might be like the simplest thing to just do. Um, but let's just do that, to be honest. So go back to the main, and we will also open the fragment. So we will do a uniform uvec2, call it u, what's it called? Screen dimension, screen dim. And then width height, so we will go down to, well, let's see. So we'll just do this right here before we enter the loop. So we'll do I32 use screen dim. I usually keep the names the same. Actually, I don't. I want this in the GL context because I want to update it when the window size is changed. So I32 u screen dimension, and then where should I put this one? So close this for now. So where do we want to put the screen dimension? Probably after we load the shader. So after we load the shader, we will do, and we're using the program, we will do GL context dot u shader dim is equal to -1, and then we need to call some function called what do we do here? So we have to basically call. We're gonna actually not do this. We will do a GL get uniform location. Now we have the program ID, and we have a string. So we need to pass this thing in as a string, which is really annoying, but that is how it is. And then, yeah. So if that is just -1, there's a problem, but for now that's fine. Then in the window resize callback, frame buffer callback, if GL context dot u shader dim does not equal -1, we will set the uniform for that. So it will be GL uniform, what the heck's it called? It's like 2 integers, so it should be like uniform 2. So it should be GL uniform 2 u. No, that's not right. Let me just look it up. GL uniform GL uniform to GL uniform just oops, any GL uniform function. There's a specific one that we want to do. You can either pass it as a vector or as, yeah, there we go. So we want to use 2UI. So this one, and then width and height. And that will be it for that one. And we also want to set this here before we enter the loop. Or rather, probably after we just assign it here. Yeah, so except this is not W and H anymore. This is GL context width and GL context dot height. So yes, good. So we will use the powers of Sam to fix that. You screen dim. So that'll fix that. Okay. Now we have this, and we have the uniform. Yeah. So first, I just want to switch this away from 0 because we aren't debugging right now. So if we rebuild that quickly. So now we will open the fragment shader. We have our screen dimensions. So we can do so first we will map this into 0 to 1 space. So that will be screen dimension.x and .y. So this is now in 0 to 1 space. So if we do greater than 0.2, this should still give us the same effect. That's right. So with that, then what we want to do is map this into the correct, the actual space that we need for the Mandelbrot, which is x should be between 2 and like -2 and 0.47. This is probably going to have to get adjusted at some point, but that is okay. So we have something that is from 0 to 1, and we need something that's from -2, it's from -2 to 0.247. So, or to, yes, it's 0. Okay, sorry. Also, we can do something a little fancy here. So first, let's do this as a vec2, and we'll call this xy for now, and xy, and xy. And then we want to, if xy.x is equal to that, let's make a little function here called vec2 map Mandelbrot for now, and it will take a vec2 v. And what we will do and we will keep this as is. So we'll assume this is 0 to 1 already, and then we will do so for the x component, the new x component is going to be v dot x times 2.47. So that is the range of it. And then after we've done that, we will go ahead and subtract. So it'll be from 0 to 2.47 now. So we will subtract 2 from that. That will give us the right range for the x, and then for the y, we do the same. The y is actually centered, so we can actually do the y differently. But let's just not worry about that. So let's do that, and then minus 1.12, and then return back to x, y. So now we have our, so now if we just do this croc properly, we'll map Mandelbrot. This one. So we've got that. And then we need to do like a little, we're gonna do like the stupid iteration method that's in the pseudocode on Wikipedia to start with. So what we are gonna do first is just do a very basic wait, I need to check this. So these are obviously not the best to include in in the vertex or in the shader, but that is okay. So we can do for let me see here. We're gonna do for we're gonna just declare an int here I for I equals 0. I believe it's just very similar to C. So I less than for now we'll just start with like 100 iterations. But that will be set up properly after. I plus plus, oops, and we are going to actually need these values. So we're gonna need x squared and y squared, and let me just check here. Where are we? So x is equal to xy dot x times xy dot x. Y is equal to xy dot y times dot y. We should probably start these out at 0. So that we can stay up here, and xx plus yy is less than 4. This is just the Mandelbrot requirement here. And then we have x naught still. So our new, well, let's actually save x naught. Interesting. So we'll just save x naught. Xy dot x. Oh, and why not? We need to actually save both of these. So let's call this xy naught, and then back to xy. And then xy is going to be equal to vec2. X is going to be x squared minus y, sorry, xx minus yy, plus xy naught dot x, and then oops, that is that one, and then for y it is just going to be 2 times this needs to be equal to xy naught to start with. Um, 2 times yeah, xy dot x times xy dot y minus, or sorry, plus xy naught dot y. And that should be that. And then what we will say is that if so normally you want to count, you want to figure out like how many iterations are occurring, and then based on that you set the color. So I am not going to do that just yet. I don't think. That will be the next step. But first, so right. So if it is not, if the if we have just used up all the iterations, then we assume that it's in the Mandelbrot set. If we have not used up all the iterations, it is not in the Mandelbrot set, and we want to color that pixel. So if I is less than 100, then color should be equal to something else. So right now we're just setting color to blue as the default. Let us do that. And then for if it is not in the Mandelbrot set, we are just going to set it to red for now, and we will see what we get. Hey, would you look at that? That's exactly the set we're just expecting to get from Wikipedia. Now, one thing I forgot to do was actually add a timer, but that can maybe, well, let's actually do that quickly. So if we go to Wikipedia though quickly, so not that one. Any of these other ones would be better, to be honest. So there we go. That's the set that we just want, and that is what we have got on the screen right now. Which is pretty cool. So what we want to do now is just figure out. Well, first things first, I want to just add the timing for this so we know how fast we're going. So that won't be too challenging. Let's get this back over here and move this back to wherever we are. So this is nice. So far, so good. Now let's add some timing to the main loop so we know how long this is taking. So before entering, we just want to store F32 last time equals 0. I believe that is right, unless my brain is completely fried at this point, which it shouldn't be. So yeah, so we have float 32, our last time is equal to 0, and then while we're in the loop, at some time, wherever, like maybe before we draw, we'll do float 32 current time is equal to GLFW get time, which is just the amount of time that has elapsed for the GLFW program in seconds. Then we will calculate float 32 delta time, which is just going to be equal to the current time. Current time minus last time. And then we will update the last time. Last time, oops. Current time, last time is equal to current time. And so we don't lag the program because I don't know how fast this is going to be. We're going to add a little bit of a U32 count, frame count, even let's call it F count. And every however many frames, I'm just deciding. So for right now, I'm just going to decide every 1,000 frames for plus F count. So if plus F count is greater than 1,000, we will print some information. So we will do a printf FPS 0.03f, I guess. I don't have a particular thing, and then probably a delta time. So delta time is equal to 0.03f in milliseconds. Slash n. So then if we go down here, so obviously FPS is just 1 over dt, and dt times 1e3 is the time in milliseconds. And then we will reset f count to 0. Okay, so now we should have some frame timing that we can just check out. Probably going to be very, very fast or not. So it's actually not that fast unless I made a typo in my code, which is also possible. Yeah, no. Oh, you know what? Yeah. I didn't make a typo. I just have... That's weird. The swap interval should not be set. I don't remember setting the swap interval, but maybe I set the swap interval. Maybe by default the swap interval is set to limited to vsync. So yeah, we don't want to do that. We want to see how fast we're actually going here. So obviously that's real time, but we don't care about that. We want to see how fast so that we know how fast or how much more complicated we can do the calculation. So swap interval. So after we make the window context current in spawn window, which is where here, we will disable vsync. So disable vsync. We want to see how fast this goes. And that was not helpful. So there we go, yeah. So that makes more sense. So 10,000 frames a second right now, which is actually pretty good because we're doing like 100 iterations in this loop for every pixel, which is interesting. So, and that is also why I set the frame count to 1,000 because, well, this is laggy. printing with printf is a laggy function. So, yeah, that is what is going to happen. That's pretty good. Let us just quickly check something. So if we go in here, do we get a little bit more detail if we increase the if we increase this iteration count? I didn't need to do that. So I'm not actually sure if we're getting any more detail by doing that. Probably we are. So that's much slower though. 300 FPS instead of 1,000. Now also the time is going to be related to the window size. So if I like shrink the window size down, um, yeah, let's just do this. Is roughly gigantic, and then let's see. So that was still like around 60 FPS. So at 4K. So even with 1,000 iterations, but 1,000 iterations might not really be necessary. So for now, we'll just leave that at 100. So I need to get it out of my head. So the next thing we're gonna do is next time. I'm going to add the I'll add shader hot reloading so that I don't have to keep. I can leave this window open, and we can just program in the shader, and it will hot reload every time I save changes. Um, yeah. So for now, though, let us. Um, well, just before we go, let us just assign a little bit of better color scheme to this. Um, how do I want to do this? So, I don't think I can do that. What I wanted to do was use like hue saturation value, but I don't have. I don't think there's a quick conversion in OpenGL for doing that. I have to actually write that function, so I don't want to write that function right now. Um, yeah, we can do something like this. So if um, yeah, I don't want to do that. So we will just set this to 255, 256. Um, and then we'll do this again down here. Oh, I guess that was another problem with that 1,000 loop, is I was supposed to check if this was less than 1,000. Let's just quickly check that actually. So I screwed that up. That was my bad. So if we do the Mandelbrot now, I don't really know if that's like any finer detail or not. Maybe, hard to say. Doesn't really matter though. For now, we'll do something more fancy later. If I is less than 256, it's as an integer, so we will do some integer arithmetic. So let us do float r is equal to, this needs to go at the end, and this will be RGB. RGB 1. So float r will be equal to I and 255. Right. It's already, we don't need to do this and part. I over 255. G is gonna be never mind. This isn't best. Okay, let's do I. I well, we'll just do some random stuff here. It's probably going to be very ugly, but we will figure that out in a second here. So I shift we can't do like a rotate. These aren't U and 8. Probably not going to appear very nice, but we will just try and see. Trying and seeing, that is what we're doing. You know what? It's better than. I don't know. It's actually looking not so bad. I was thinking it was going to be a little bit uglier. You know what? That's yeah. Yeah, you know, it could be worse. What if I do something a little bit more random here? So, uh, oops, don't need to compile the C program. So yeah, you know what? That's not bad. That is not bad at all. Um, what if we set the Mandelbrot set to something a little bit better? Um, well, I just don't want it to be so bright, but I still want it to be visible that it's different. Yeah, that's a bit better for now. So there we go. Say that is pretty good for today. Um, Unfortunately, we had to waste a lot of time doing some annoying debugging at the start because of my tired brain putting some typo. But you know what? This is looking pretty good so far. So next time, what we will do is add shader hot reloading so we can change this on the fly and watch it as it's going on. Um, we might also want to fix the aspect ratio um, so that this looks correct. I haven't decided that yet. Um, and what else? We need to start adding the zooming. So probably we'll start by just taking the mouse position on the window and zooming in there. But later on, we want to actually set it to animate so that you set a position and then it will just zoom in forever. And that would be pretty cool. Um, yeah, this is actually you can also draw like some Julia sets. So I think if you just set C to like some different values, um, right now I think C is just set to 2. Is that right? Uh, I'll figure that out later. Yeah, so cool. Um, Thanks anyone who was watching tonight. And I will see you all. Let me just see here. Do we have any? No, not too much right now. But that is all okay. I will see y'all another day. Alrighty. Take care.